Hello everyone, I'm Cesar Rodriguez, and today we're going to be having an intro to SPSS workshop. And I really want to take this opportunity to thank everyone that's here in person and everyone that's here online. And a very special thank you to Texas A&M International University and its Department of Advancing Research and Curriculum Initiative PARC for allowing me to do this presentation for everyone today. Today we're going to have an overview of SPSS, which is the focus of the fundamental skills for independent and dependent variables, levels of measurement, measures of central tendency, and measures of dispersion, and graphs. We're also going to be uploading some of our data to SPSS 28, recoding some of our data, transforming variables, and using graphs. Next, I would want to end up going for the idea. Next, I want to end up saying the concept for the independent variables. Independent variable is a variable that is a standalone variable and does not change by any other variable, whereas our dependent variable changes in response to the independent variable. For example, independent variable can be studying and its effect for the hours that you study towards the test score or grade that you end up getting as a result. Also, we can have two independent variables such as studying and sleep on its dependent variables result of test scores. Next, I want to end up saying how there are 4 levels of measurement, which are nominal, ordinal, interval, and ratio. Nominal is just a list of categories that all have the same value that equal 1. For instance, we can use ice cream flavors, which vanilla, chocolate, strawberry, mint, and candy bar. Ordinal, there is a rank order to the value, and we have an importance. For instance, what is your favorite ice cream flavor? For me, it would be 1 candy bar, 2 vanilla, 3 chocolate, 4 strawberry, and 5 mint. Whereas interval is a range from least to greatest. And our interval, we could use the example of ice cream again as what temperature should we eat ice cream eaten at? Would you want to eat it at 24 degrees Fahrenheit where it's hard to scoop up, or 100 degrees Fahrenheit where it's soupy? Or you could choose something in between where it could be 36 degrees Fahrenheit to 42 degrees Fahrenheit, so you're able to scoop it and still have it as a treat. Next, we're able to end up using ratio. Ratio, there is a true and absolute zero. For instance, how many times have you ate ice cream this week? It could be 0 that you ate it, that you have not eaten any at all this week. It could be 1, 2, 3, 5, or 7 times. It all depends on how many times you or another individual ate ice cream that answered this question this week. Next, we have measures of central tendency, which are mean, medium, and mode. Our sample problem of 12, 10, 19, 19, 19, 8, 145, and 75. We have this as our sample problem, and we want to first look at what the mean is. And the mean, we add all the numbers together and divide by the number of terms. So we see these 8 variables, we want to divide by 8, and we want to add together 8 plus 10 plus 12 plus 19, 19. And we want to add together 8 plus 10 plus 12 plus 19 plus 19 plus 19 plus 75 plus 145 to equal 307. And we divide 307 by 8 to equal 38.375. Our mean is obtained by arranging your data from least to greatest and finding the one that's in the middle. And if there are 2 numbers in the middle value, then we have to add those 2 numbers and divide it by 2. So for our example, it would be 8, 10, 12, 19, 19, 19, 75, and 145. And we're able to have it equal as 19 plus 19. Once we cross out those sides, and we're left with 2 numbers in the middle, it's 19 plus 19 divided by 2, which is 38 divided by 2 to equal 19 overall. And our mode is the most frequent number. So for our example, we have 19 occurring 3 times, so that's why 19 would be our most frequent. Using SPSS, your most frequent observation would be shown as 1 digit, but it could have multiple digits averaging out to the same number. It's showing you the first one that meets that criteria. Measures of dispersion is the standard deviation, or sigma, is a measure of how dispersed the data is in relation to the mean. Low standard deviation is a result. Low standard deviation, the data is clustered around the mean score, and high standard deviation, the data indicates the data is more spread out. And what is the minimum and maximum in standard deviation? The relationship is sometimes referred to as a range rule for standard deviation. The range rule tells us that the standard deviation is a sample is approximately equal to 1/4 the range of the data, with an equation of S for standard is equal to the maximum minus the minimum score divided by 4. For instance, you can have a minimum number of survey participants with an age of 18 and a maximum number of 80 for age. But standard deviation cannot be good or bad because it simply tells us how spread out the data is for its value in the sample. For instance, we could end up having it where it's 34.13% of the mean away from the mean in either direction. And then we can also increase it so that way it's 95.44% of the mean, and increase it again to have 99% confidence of 99.72. Again, it would be 34.13 plus 13.59% of the mean plus 2.14. So equal the distance for its mean score to be a total of 99.72% of the mean score. And for graphs, when you have a nominal graph, which is our frequency, we want to end up having it be frequency in bar charts. Whereas if we have a scale, which is more for the means of standard deviation, we want to end up having a histogram. Next, what I want to end up showing is I'm using virtual desktop at tamu.edu, which is a virtual desktop that we have. Virtual desktop is also available depending on the classes, and some students are able to apply so that way they can use the access code for SPSS. SPSS is also available on TAMU computers that are within TAMU's network. So right now we want to end up finding SPSS, and it is this icon right here, which is the sigma, and it's IBM SPSS statistics. And if we don't have this icon here on any of the computers here at TAMU, we're able to go into the search bar and type in SPSS. And it should give us the app for IBM's SPSS statistics. And we need to give it a moment to load. So now that it is loaded, we want to end up exiting out of the welcome part. And we want to end up opening data. So I do have a file that's an Excel file, and we're able to go to File, Open, Data. And I know it's under downloads, but it's not showing up under downloads. That could be because of files type. And the file type, what they're looking for right now is SPSS statistics.sav. So for it, we have to scroll all the way down to all file types. And from all file types, I know that my Excel spreadsheet demo is here, and we're able to open demo. From opening demo, we need to give it 1 moment, and we want to leave it on its default settings. Now that its default settings are done and we have our SPSS data for demo, we're able to end up seeing some of our information, which are our variables. What we see right now is that there are 7 visible variables up here in this corner. And we know that they're variables aside from it having var on the top. We know that the variables are done by columns. So for instance, we have ID number, age, gender, marital status, address, income category, and job category. All of our variables have to be a unique name that cannot have special characters, and they cannot have any spaces in between. Next, we end up having our cases be individual and unique cases. It would not be good to have cases that are similar all the time, such as A001, since some of the information could get jumbled up and it's easy to get the wrong variable or the wrong case depending on what you're interpreting. So it is better to have a more unique stance for the information category. Also, it is not ethical to use people's names if it is done for survey purposes. That's the reason why sometimes you need to give it a special code such as A equals 001. And you want to have it unique where you're also able to use underscore as a space. So from knowing that information, we're able to see some parts of our information right here with marital status where it has these dots. All these dots on marital status means that there's missing data. So for participant A03, the participant did not say if they were married or not, which 1 would be married and 0 would be that they're not married. So since they did not answer it, it has a period in between. And that is a true statement, true valid response. So now that we're able to identify and see some of these characteristics, let's scroll all the way down and create a case. At the moment, we have 201 cases, but for our demonstration purposes, let's create a case of A0202 with an age of 80, and it could be a female. And our marital status, it could be missing right now, but let's say it's a 1. Address, let's say 32. And income category is a 2, with job category over 2 as well. The information for address, income category, and job category are on an Excel spreadsheet data, which I do not have at the moment, to actually give the codes or recoded data for what the address, income category, and job category are at this moment in time. But since we did end up having a new case, we can scroll up and observe some of our information. For instance, with gender, we can scoot it over a little bit and notice that gender is done with an F and an M. For research purposes, we would want to have it dichotomized as a 1 or a 0, such as marital status. But for our information purposes, we want to end up having it where we look at gender and see why it only has 1 space for F. That could be an issue having to do with our variable view. But before I click on variable view, we're able to notice that some of our variables have a ruler and others have a circle. When I go on variable view, we're able to see that our variables such as ID number are string and age is a numeric. Again, gender is a string variable. When we click on it and the 3 dots next to it, we're able to see that variables can be in different types, such as numeric, comma, dots, scientific notation, date, dollar, custom currency, or string. And right now we want to leave it as string, but we're also able to see that the width is different from the width. Let's say we want to end up having it as 8, so we can actually type in female and male. And from here, we're able to type in female. In the bottom one, we can select male. And right now, we're able to run a frequency distribution by going to Analyze, Descriptive Statistics, Frequency, and select Gender. From gender, we can move it into variables, and we're able to see under statistics, we can select the mean, median, mode, standard deviation, minimum, and maximum, and hit continue. From here, we're also able to see that there's different charts that can be used. For instance, right now, since we know it is a ordinal, we're able to use a bar chart and hit continue. Now from our variable view, we're able to see that the F of female is 100 cases and female is 1, whereas male M is 100 cases and male being written out as 1. So this is the main reason why we do not want to end up changing our original data set, our original data variable. And instead, we always want to recode into a different variable. So if I hit back and back, it'll change the data to go back to the way it was of F and M. And from here, we're able to select transform, recode into a different variable, and select gender. From gender, we're able to move it over and give it a name. So we want gender 2 with the label of gender 2. And change what it contains an illegal character. The illegal character again is a space. We're not able to have a space, so we're able to have it as gender 2 by itself, or gender 2 with an underscore. By having the underscore, it allows it to have a change. And we can select our old variables. Our old variable of F, we want to have it as a new variable of 0. And we're able to select add. And our other variable of M, we can select it as 1. And we want to select add again. and continue. From here, we now have our new variable of gender, and our variable is showing decimal spaces. A reason for this, again, could be from our variable view, where we look at our variable view and decimals have 2. So our general rule of thumb is to have 3 decimal spaces for data that is not dichotomized. Dichotomized is that it's a 0 and a 1. So for reporting purposes, for statistics, let's say for regression, it's better that we start off with 3 decimal spaces, and then we're able to move it down to 2 or 1, depending on what our output data equals. So right now, I'm going to leave it as 0, so it can stay dichotomized of 0 and 1. And from here, we're able to select Analyze Again, Descriptive Statistics, Frequencies, and we ended up changing a variable. So now let's select our new variables or our old variables and put them in. So we have age, marital status, address, income category, job category, and gender, right? Gender 2. And we're able to input that into our data. Next, from here, we're able to leave our information the same of mean, medium, mode, standard deviation, maximum, and min. Hit continue, and we're able to select our mean, medium, mode, standard deviation, maximum, and we can also select for distribution of skewness and kurtosis to select continue. Next, we're able to do charts, but this time we can try doing a histogram because some of our ordinal variables would still show a histogram or a bar chart for its frequency at the moment because they are dichotomized. So we can select OK and OK to find our new information. From our new information, some people would want to see our variables in the column row, whereas others might want to see it in the mean row, depending on how long of a variable list you have. For instance, age is a very long category, and some might want to have it smaller. So in this instance, we're able to select our charts, go to edit. From edit, we can go to pivot, and we can hit transpose rows and columns. Once we transpose our rows and columns, we now have our variables on the side, which are highlighted, and we have our information for valid, missing, mean, mode, standard deviation, skewness error, kurtosis, and maximum min. So it could be easier to read depending on how many variables you have, such as age, but some instances, people would prefer having it the way the SPSS originally puts it. So we're able to go to transpose rows and columns again to go back to our original format. Since they can copy this variable, export it, and they can export it into a Word document, or they can also export it into an Excel document. You can also export it into a PowerPoint if need be, and there are other ways to import and export your data. From our data, we're able to end up seeing that age, marital status, address, and income category, job category, and gender category, the only one that is. We're able to see that from our variables that most of our variables do not have any missing data except for marital status. Marital status has 5 missing. And we're able to see that they have a mean when they add them all up and divide by the number of terms, which in this case would be 202. It equals to 42.83. And our mean is when they put them all in a row from least to greatest and start sketching them off. The number that we end up having is 43.50. And our mode, which is the most frequent, is 51 for age. And again, this can occur where it is 51 showing you only the first instance, and there could be multiple instances of the same mode, but SPSS only shows you the first one. And we also have standard deviation of how far it is away from the mean, and our skewness and kurtosis scale. We also have our maximum and minimum. So we have a minimum number of age of 19. So the youngest person is 19 and the oldest person is 80. Next, we're also able to see marital status, that 5 are missing, but we have 103 that are not married and 94 that are married. Address, we have a lot of addresses that we were able to change as well. And income category, the one that we have the most of is 2 with 81%, and it makes up the cumulative percentage of 57.4%. And that ends up changing since our valid percentage is 40.13. So 40% of the population for income category make 2. Excuse me. Whereas our job category of 2 is 79, which has a percentage of 39.1%. And it can make a cumulative score of 71.8 when you add them together. Whereas gender, it's just a dichotomized variable of 0 and 1. Age, we end up having our information as it goes up and down, where there's very few for standard deviation from our mean score, which is here. Our mean again is 42.83. And it falls within our information showing that 42.83% of the population is the average age. And there are less people that are 80, between the ages of 60 and 80. And people that are under 20 is small. We're able to see that again by scrolling up and seeing that only one person is 19 and one person is 80 for the information. Our marital status, using the chart, we end up seeing 0 is higher because we have 5 missing for our data. Next, for our address, this one is more of a nominal since it is just showing you the address, but is a little bit ordinal because it has a meaning behind it. Although in this case, all of them equal 1. It's just the amount of people that are there. Address is ordinal at this point because it's the amount of people that are within the area. So that's why for area 2, we see that there are more people in area 2 for address. For this information, that is on a separate data sheet that I do not have at the moment. This is for practice. Again, we're able to see that our income category of 2 is the highest with 80 people, and there is no missing data when we scroll down. And job category, again, it's 2, with their gender being even at 50 and 50. 50% males, 50% females, and 0 in our case was females because that's how we coded it, and 1 in this case, because of the way we coded it, is males. So from this information, we're able to change and transform our variables. We're able to go to recode into a different variable, move gender, and we can select age. From age, we're able to select that into a new variable and give it the name age 2. And then label age 2. Change, and I was able to select full linear. So for this, we're able to select a range. So we're able to select 19 through 30. And we can give it a value of 1 and select add. Next, we're able to go 31 through 50 and give it a value of 2. Select add again. And we're also able to select 51 through 80 and give it a value of 3 and add. We're able to hit continue And we already changed our variable. Now next we can select OK. So when we look at our variable view, we now see that there is a new variable that is there, and age has a decimal spot. From here, we're able to see it again, where we now have it as 1s and 3s. We can change our information by decreasing the decimals, and next we're able to go back to our data view and see our new variable. From our variable, we already changed this one. From our variable, we already changed age. We're able to go to analyze, descriptive statistics, frequency, and select our new age. But before we do that, we're able to select, hit shift, and go all the way up again to move our old information, and select our new information of age 2 into our variables. Keep our statistics the same of mean, median, mode, standard deviation, maximum, and min, and skewness and kurtosis. We select OK. And for this one, we want a bar chart. We're able to select OK and OK. So our new information is giving us age 2, where there's 202 participants, 0 missing, with a mean of 2.07, a median of 2, and a mode of 2, since that is the most frequent. We also know that it does have a skewness of negative 1.08 and a standard error of 1.71, with a kurtosis of negative 1.103. And error kurtosis is 0.341, with a minimum score of 1 and a maximum of 3. We are able to change and transform our variable since it is a large percentage of people with different ages. We now put it into a range. And we created it more into a categorical or nominal variable, since we decreased the amount of people. And since we decreased the frequency, since we transformed a variable to be between 1 and 3, and we added some of our variables together, so that way it equaled 19 through 30, equaled 40% of the population, whereas 2 was 94% of the population. Again, this was from 31 to 50, and 3 was part of our population's age from 51 to 80 to equal 61% of the population. And our population score changed its frequency level as well. From here, we're also able to select, analyze, descriptives, and we can select. From here, we can select graphs, chart builder, okay, and select the chart that we want, which could be gender and age. We select one of them as gender and one of them to be age. Next, we select chart builder and okay. From chart builder, we're able to end up having a bar graph, putting this in, and let's say our y-axis is age, and our x-axis is gender. So now we have a category for the counts, and again, let me just put this in here once more, is age and gender, and we're able to select OK, and it gives us the age, and it gives us the gender 2 category, which is our dichotomized variable of 0 and 1. We can also end up seeing that from our categories again of gender, but we can also include our original age. And we're able to end up seeing that gender, it was from 0 to 80, and gender, we're able to see that female gender was between 0 to 80, whereas male gender is below 80. So it could be 78. And next we want to save our data. So to save our data, we already have our inputted statistics here. So next we're able to go to File, Export. Instead of a Word document, we're able to change it into an Excel file of Excel 2017 or higher and select OK. So that exports our data. From our exported data, we can open Excel, right by your search bar. Have the Excel app open. Look at our files. This PC. And output. Since we just had it, it is selected in documents, and we have our output data. With the time that we ended up creating this data. All of our information is here, and we're able to use Excel to change some of our variables and statistics as well. This has the full output data, and it also has the range that we have. Again, a way that we're able to save our information is to go to File, Export, and we can choose a file type. For right now, we're able to select it as Excel 27, 2007 or higher. Right now, we're able to select to save our data, and we're able to go to File, Export, Excel, and let's go to Excel 2007 or higher. Select OK, and this one already exists. We can go to File, this PC, output, and this is our file information. But since some of us are using virtual desktop, we want to save the file again. So we can select Save As, this PC, desktop. So we're able to open our file as output and email it to ourselves. You're able to select send it on OneDrive, or you're able to use your email. For me, I already have it on Gmail. So I select my Gmail. From Gmail, you're able to hit compose to, you want to send it to yourself. So for me, I would put the real Cesar rock 2 at gmail.com. The subject of SPSS data. And I would attach my file by going to my desktop, hitting output, open, and send. And thank you very much for being a part of this video.